cameras, that is camera A and camera B. Suppose the price of camera A is $200 and price of camera B is $300. We have also been provided with the quantity demanded model for both of these cameras, and the demand model for the camera A is NA is equal to 195 minus 0.6 PA plus 0.25 PB. Here NA is the total quantity demanded or total quantity sold. If there is no relationship between the price of camera A and price of camera B, the maximum quantity of camera A that can be sell is 195. And if there is a relationship, then an increase of $1 in price of camera A will result in reduction of zero point 0.6 unit of camera A, and an increase in the price of camera B by $1 will result in the reduction of camera A quantity demand by 0.25. In the same way, if there is no relationship, we will be able to sell maximum of 301 cameras for camera B. And if there is $1 increase in price of camera A, there will be increase of 0.08 of quantity demanded of camera B, and increase in $1 of in the price of camera B will result a decrease in zero point 0.5 units of camera B. So let's determine the demand of A and B using these models. Here we have set the formula where we have 195 minus zero point 0.6 multiplied by price of camera A and plus 0.25 multiplied by price of camera B. In the same way, we have 301 plus 0.08 multiplied by price of camera A minus zero point 0.5 multiplied by camera B. So we have now the quantities demand for demand price. We have the demanded quantity for camera A and camera B. With the help of these demand, we can determine the total revenue for camera A and camera B. We have already supposed that the price of camera A is 200 and price of camera B is 300. We will multiply the demand of camera A with the price of camera A, and same way we will multiply the price of camera B with the demand of camera B, and then we will sum up these two revenues and we will reach at the total revenue. This is the model for the revenue for both of these cameras. But our objective is to determine a price of both of these cameras where this revenue is maximized. We need to determine the price of both of these cameras where the revenue will be maximized, as both of these are the substitutes. Increasing the price of one will also affect the demand of other. So we will need to determine the price of these cameras in a way that will maximize our total revenue. Suppose we need to vary these revenues from 250 to 500. On one row we will take the price of camera A, 260 to 70, take this till 500. We have taken the price of camera A on row 21, and now we will take the price of camera B on column B. In the same way, we will need to change this price till 500. So I'll take this till 500. Now I have taken both of these prices, and my objective is to maximize the total revenue. I need to determine the price of camera A and price of camera B that will maximize our total revenue. So we can do this with the use of data analysis, what if analysis. That can we will do. We go to data, then we will select what if analysis, and then we will create a data table. Here the row input is the price of camera A. The price of camera A is 200, and then we need to put the column input, that is price of camera B. By putting these values, we will click OK and it will create a table. What does this table is showing? This table is showing that if the price is 250 and for price of camera A is price of 250 and price of camera B is also 250, the revenue will be 75875. At the price of 260 for camera B and at the price of camera 260 for the revenue will be this. We need to determine the point where we have the maximum revenue. So I use the formula of maximum by giving this range, and the maximum revenue is 8499. I need to find the 8499 within this sheet and look in values. Here the value, here this is the maximum revenue that is generated. So we can say that if the price of camera A is 270 and price of camera B is 390, then we will have the maximum revenue. Then we will have the maximum revenue. So I hope this will helpful for you people. Thank you very much.